There's an additional pathway we can take an alkene to result in an epoxide without relying on peroxy acids, such as m-CPBA. And the first step of this process results in first forming a halohydrin product. The first part of this process relies on forming the halohydrin so that we can have the hydroxyl and halogen groups anti-perplanar to one another. The second step of this two-step process involves treating with a strong base to deprotonate that hydroxyl group, which creates a strong nucleophile in the correct orientation to an adjacent carbon containing a good leaving group, which will induce an intramolecular SN2 reaction within the molecule, a reaction theme we've seen prior. However, in this case, it's happening within the molecule. The nucleophile attacks, kicking off the halogen from the adjacent carbon. We are left with our epoxide product without needing a peroxy acid. So let's put it all together and review an example of taking an alkene to an epoxide through this two-step process. First, we'll react the alkene with the halogen to form the three-membered cyclic aluminum ion that will get attacked at the more substituted position by water, forming our oxonium ion that gets deprotonated to result in our first product, the halohydrin, which specifically can be used because the hydroxyl and halogen groups are placed anti-perplanar to one another, which will allow for the backside attack of the SN2 reaction to occur later on. Next, we'll treat the halohydrin with a strong base to remove the hydrogen from the hydroxyl group, creating that strong nucleophile in the correct orientation for the intramolecular SN2 reaction, giving us our epoxide product.